Okay, so in this video, let's understand slope and area concept. See guys, if ST equation is given, so with the help of ST equation, again I'm repeating, ST means this S can represent distance also and this S can represent displacement also. Only one thing is different. See, distance and displacement, they will become same if you have motion in a straight line. Okay, but if motion is on curve path, on any circular path, elliptical path, in that case distance and displacement will not be same. Then how will you know that it is distance or displacement? Then you don't have to bother. Manufacturer of the question, author of the question, teacher of the question, they will mention in the beginning itself that this S is representing distance or displacement. Okay, so no need to bother. But if motion is there in a straight line, then they can give you this as distance also and displacement also, because anyway answer is going to be same, right? So if ST graph is there, then with the help of if ST equation is there, distance time equation, displacement time equation is there, then what are the things you can calculate? You can calculate that at a particular time, suppose t is equal to 2 seconds, how much distance the vehicle has covered. Okay, means total distance traveled, right? Suppose I want to know that one very extra important thing. Suppose you have ST equation. In this ST equation, I am putting t is equal to 2 here. It means what? Total distance traveled in 2 seconds. Then I am putting t is equal to 7 here. It means what? Total distance traveled in 7 seconds. Means what? Object was here and object traveled this much distance in 2 seconds. From here itself, object traveled this much distance in 7 seconds. So this is what we can calculate with the help of these equations. But suppose if I want to know that how much distance will be covered between these two gaps, I mean from time t is equal to 2 seconds to t is equal to 7 seconds, how much distance was traveled? Now see, here one big confusion. What I'm asking, I have ST graph. In this ST graph, if you put t is equal to 2 seconds, then suppose this is the starting point. So from this starting point, vehicle will go this much distance for t is equal to 2 seconds. So you can calculate this distance as suppose S2. Okay, now if you put in this equation t is equal to 7, then suppose from the origin you are putting t is equal to 7, then automatically from the origin it will take you to this much distance in 7 seconds. Okay, means S7. But if you want to find out gap, like how much distance was traveled between this, so this is the distance traveled, right? 2 seconds and 7 seconds. Then if I will ask, how will you calculate that? Then two type of students are there. Some students can say, sir, substitute t is equal to 5 seconds. And some students may say, sir, you find out your S2, you find out your S7 and subtract both the thing and you will be getting distance traveled in this gap, in this 5 seconds. So see guys, we have two types of 5 seconds. One 5 second when you will put t is equal to 5 in this equation, and one 5 second which is the gap between these two. They both are different. Okay, and how will you understand they are different or not? It depends on the language. Are you able to read the language of the question or not? Okay, so in case of t is equal to 5, if you are substituting t is equal to 5 directly here, then you will be getting again a distance covered in 5 seconds. This distance, you will not find the distance between 2 and 7. Understand one logic. See, if object is accelerating, then see, I have not taught you the main concept of acceleration yet. It is about to come. All the three equations of motion, all the things are on the way. Okay, don't worry, but let's understand this. If object is accelerating, then in first 1 second object speed will be slower, so distance covered will be less. In next 1 second object speed will increase because of acceleration, so object will cover more distance. Then in next 1 second object speed will further increase, then object will cover more distance. Then in another next second object speed will further increase, then object will travel more distance. So understand here, suppose I have data, I have some data like this was 0 second and this was 100 second. So suppose when 11 second and 12 second distance, if I want to find out the middle distance, and 80 distance and 81 distance, I mean time, when time was 80 and when time was 81, do you think, see here also time gap is 1 second, here also time gap is 1 second, but do you think this distance and this distance will be same? No, they will not same, because body is accelerating, and if object is accelerating, then when time will increase, speed will increase, so distance covered will increase, right? That's why here also you think in this way. If question is asking how much distance was traveled in 5 seconds, this question is different. But if they are asking from t is equal to 2 seconds to t is equal to 7 seconds, in between how much distance was traveled, that is also 5 second gap, but this 5 second will give you different and this 5 second will give you different. For example, just understand in this way. Suppose I am giving you s is equal to 2t square as a fresh question. Take this as a fresh question, s equal to 2t square. And in this question, I want to show you, I want to ask that first question, distance traveled in make it easier, distance traveled in 3 seconds. And second question, distance traveled in t is equal to 4 seconds to, make it more easier, t is equal to 1 second to t is equal to 4 seconds. Okay, now you see in both this, and take one more question, distance traveled in t is equal to 2 seconds to t is equal to 5 seconds. Now see, in the first question I am asking direct distance traveled in 3 seconds. It means this question is framed from origin, like origin from 0, but these two questions are not framed from 0. Here also if you see time gap is 3 seconds, here also if you see time gap is 3 seconds, but all the three questions are different. Damn sure in the first question answer will come less, in the second question answer will come more, and in third question answer will come maximum. Okay, let's do this. So I am solving first question. In first question, when time is equal to 3 seconds was there, so your equation is there, right? S is equal to 2t square. In this equation you substitute 2 into 3 square. So here you are going to get 9. So 9 into 2 is 18 meter. Okay, now you go for the second question. T is equal to 1, to t is equal to 4. What is your procedure? So for t is equal to 1, you find out your distance s1. Then for t is equal to 4, you find out your distance s4, and then subtract both as s4 minus s1. Okay, this will also be distance traveled in 3 seconds, but this is gap. Okay, so in 1 second it is going to be 2 into 1 square, which is going to be 2, and in 4 second it is going to be 2 into 4 square, so it is going to be, now see here, when you are doing 4 square, then how much answer will come? 16. Then 16 and 4 you multiply, 2 you multiply, answer will come 32, right? And then subtract both, so 30 minus 2, answer, sorry, 32 minus 2, answer is 30. So you can see this gap is 30 meter, but initial was 18 alone. It means what? See here, it means when time was 0, vehicle or any body started, and when the body finished 3 seconds, then distance traveled was only 18. Total distance was 18. Now meanwhile I am targeting this time when t is equal to 1 was there, and then from t is equal to 1, t is equal to 3, t is equal to 4, I am going to t is equal to 4, and I am counting in this gap total distance covered. This was the second question, so this is coming as 30 meter. Okay, in same way I have the third question. So if you are watching the video seriously, then you find out the answer for third one. Okay, that's all. Now you understand. I hope you are able to feel this part. So pause the video, solve this question, and then comment. Let's go ahead. So ST equation totally clear. In ST equation, what is the job we are doing? In ST equation, we are finding out like total distance traveled in gap. Okay, what more we can do? Third point, in ST equation, with the help of ST equation, we can find out VT equation. Okay, and if ST equation is given, we can also calculate average velocity or average speed. We have seen those kind of examples. From ST equation, if you are able to find out your VT equation, then you can find out your instantaneous velocity also. From ST equation, you can also judge acceleration is there or not. Okay, how can you judge acceleration is there or not? So from here, just little idea. See, if acceleration is there, then motion will be non-uniform because there is something called velocity. So if velocity is changing, then motion will be non-uniform. If velocity is constant, then motion will be uniform. Always remember one thing. Always, velocity is the combination of speed and direction. Velocity is the combination of speed and direction. If any one will change, either speed or velocity, either speed or direction, then both will change. I mean to say, if speed or direction any one will change, then velocity will change. And if velocity is changing, then definitely acceleration is there. And you can calculate acceleration. So we have ways to calculate acceleration. With the help of three equations of motion, we can calculate acceleration, or with the help of vector, we can calculate acceleration. Okay. When to use these three equations, when to use vectors, these things I will explain in upcoming topics. Okay. So I hope this part is very well clear. Now few more things you take note. I have explained in last video also. Like if ST equation is given, from this ST equation, if you differentiate one time like ds by dt, then it is nothing but velocity. So you'll be getting velocity time equation. And in velocity time equation, you give one more differentiation, so that you can say ds by dt square, or you can say dv by dt. So this will give you acceleration. It means what? You got AT equation. Okay. Now I will show you some examples. S is equal to 4t minus 3. And I am saying another example. S is equal to 2t square plus 2. And I am giving one more example. S is equal to t cube minus 3. Now see, we will differentiate all the three equations. So if you will differentiate for the first time, that is nothing but ds by dt, then you will be getting v. Then in differentiation, what are you thinking? This t will become 1, this constant will become 0, so you'll be remaining 4 alone. Okay, so your velocity is 4. Okay, now differentiate. This is very interesting. Now differentiate second equation. ds by dt means velocity. So this t square, when you will differentiate, will be getting 2t. So already 1 2 is present here, so it became 4t, and constant will become 0. Now see here, velocity is 4t. Now focus on third equation. S is equal to 3t square, and this constant will be 0. So 3t square. Sorry, not S is equal to ds by dt. So you got your velocity. So you can see what is difference between this answer, and this answer. Okay, you can clearly see this velocity is only 4, but in this velocity 4t is coming. 4t means this velocity is not constant, it is depending on time. Means if you substitute t is equal to 1, t is equal to 2, t is equal to 3, then your velocity will keep on changing. But understand one thing, in the first equation your time parameter is not there. It means what? Where will you substitute t is equal to 1? Where will you substitute t is equal to 2? It is not at all available. So t is equal to 1 2 3 4, you cannot substitute. It means what? Velocity is not depending on time. So what can you say? Can you say velocity is constant? Yes, you can say velocity is 4 only. It will not change with time. So if velocity is 4, it is not changing, then it is uniform motion. Uniform motion, correct? And if you differentiate one more time this equation, differentiate one more time, so you'll be getting d2s by dt square, or you can say dv by dt, or you can say acceleration. So you know, when you differentiate constant, your answer is 0. You can clearly see we got our beauty. Acceleration is equal to 0, right? But in second equation, this is not the case. Time is present there. So at different timing, your velocity will be different. Velocity is changing. It means definitely acceleration is there, right? How much acceleration is there? Very simple, very simple. Take this, differentiate one more time. So d2s by dt square is equal to dv by dt is equal to acceleration. Okay, this acceleration will come how much? We are differentiating 4t, so t will become 1. So 4 is remaining, so 4. We got our acceleration. So now you check, your acceleration is constant or it is also varying? It is also variable? No, acceleration is constant. Anyway, acceleration is there or not? Yes, it is there. In first, it was not there. So it was uniform motion. But now in second example, we are getting acceleration as 4. 4 means acceleration is constant. Acceleration is constant. It means it is there. It is there means if acceleration is there, then definitely velocity will change. And if velocity will change, motion will be non-uniform. Correct? Motion will be non-uniform. Very well done. Why my lecture series is very important for you and for your friends? Because I practice, I give you so many numericals to practice. I give you feeling. You can feel this. And very soon after kinematics, you will realize that you are able to crack any question by your own inputs. You are going to be master in physics. So slowly, let's complete this lecture series. Now, in same way, here third equation is very interesting. If I will differentiate one more time, d2s by dt square is equal to dv by dt is equal to acceleration. So differentiate. So you are going to get this t square we have to differentiate, so it will give you 2t. So 3 is already there, so 60. So it is more dangerous equation. Why? Because acceleration is also not constant. You know, it happens in rocket where acceleration is also not constant. It happens in pendulum motion. There also acceleration is not constant. Anyway, these things are very important. Slowly when chapter will come, when I will teach you gravitation, that time I'll be teaching you rocket. When I'll be teaching you wave and oscillation, that time I'll be teaching you pendulum. So there I will again link all these concepts one by one. Very important concepts. Okay, so that's why I used to write on my thumbnail best physics ever, because you will feel everything how things are going on. Okay, let's meet in next lecture.